Hello, welcome to AP Physics with Christian Billings and me, Gohrick. This is our problem number 5. This is our problem here. So to start, we have our free body diagram right here. We have our M and we have our 2M. We have the weight, the tension of the rope on 2, and the weight of 2M. Now the weight is going to be double the weight of M because it's 2 times the mass. It is also rotating to the right, therefore the mass is greater and the tension is less. For part B, this is the translational motion. We have our sum, our F net equation equals ma. We have the tension minus the weight equals mass times acceleration. We subtracted the weight, which is 9.8, gravity. So tension minus 9.8 equals 1a. Now on the other side, we have another F net equation. For 2m, it's the same, basically the same thing, except we're subtracting weight minus the tension. And the weight is 19.6 because we multiplied 9.8, which is gravity, times 2 because it's 2 times the mass, and equals 2a.
So for part B, so this is now we have to find the analogous equation for rotation motion of the pulley. So here's our free body diagram of the pulley. We have the normal force on the table, on the pulley up. We have tension on the left side by M on the pulley, then the tension on the right side by M on the pulley. Then we have the weight also by the pulley. So so basically you can find it by tension toward its inertia times acceleration. Here we have T, 2M, times the radius minus Tm times the radius equals 1.5 M times the radius squared. So angular acceleration, which is the rotational motion equation, equals T, 2mr minus Tmr.
And now for part C, in order to solve for acceleration, we're going to stack the 2 equations here. That will cancel out the t, and we'll get 9.8 equals 2a. Divide 2 by both sides, and we get acceleration equals 3.267 meters per second squared. Back to you, Christian.
So in part D, we're going to solve for the tension in the segment of the cord for the mass of block M. Here it is. We use the same equation as the sum of forces equals ma for block M. So it'll be tension minus 9.8 equals 1 times the acceleration we just solved for in part C, 3.267 meters per second. So there it is, just 1 times 3.267 is obviously 3.267. And you add 9.8 and the tension is 13.067 newtons in part D. And for part E, we're going to solve for the normal force of the whole entire apparatus, the force up. So we got the tension in part D, which is the tension of block M. And we also have the weight of the pulley, which is 68.5 newtons. 68.5 newtons because the weight equals 21 times 9.8, which is the whole weight of the pulley is 7 newtons, so you multiply that by the gravity. And then we solve for the tension in part 2, which we didn't have, but it helped us solve for that. So it equals 19.6 minus t equals 2 times the acceleration of 3.267 meters per second squared. And the eventual answer, we divide by -1 is negative, so it gives us 13.066 newtons. And to add all those forces up, to be 13.067 newtons plus 68.6 newtons plus 13.066 newtons, which is the eventual answer, 94.73 newtons. And that is the final answer of the whole entire normal force applied with a pulley. Thank you very much, and I hope you enjoy the presentation.